Hello again. Okay, so last time we left at the part where we were going to figure out our stepping, how to solve the stepping. So why do we have stepping? We have stepping because maybe our object is moving too fast. We have stepping. Maybe our source is not generating enough material in between frames, and there are many reasons, right? Okay, so how do we sort this out? Okay. There are many ways we can interpolate in between frames. We can use substepping, but substepping generally is not very good for our simulation times. We can, in a scenario like this, we can randomize the takeoff speed to back and forth between the particles. So originally coming out from the frame, it's going to have a better distribution. But you ideally want to do that just for the trajectory side, so you don't want to do something extra because you don't want points filling up these streaky gaps, but you want points distributed more evenly in between the towards the direction of these particles. Or the other thing you can do that is a bit easier is that you can take advantage of the tools that are given to us already. So in this example now I'm going to use let's see, we have the velocities, right? Okay, we have the velocities, so I guess we can put a trail swap. Trail swap has one trick up its sleeves that we can use. Preserve original trail length 4 and trail increment maybe 0.3, so that kinda does a little bit of a better job. So we have lots of points kind of filled in between. Okay, and then what else we can do is that this generates additional points, right? So we need to be remembering that as well for the next few swaps. So the other thing now we need to do is that we can put a point replicate as well. That's another way to do it. But let's put, before you plug it in, put that number down, because if you have too many points, you're gonna run into cooking issues. So what we can do is that, let's say we want to keep the input attributes, and then everything turns to a different random color. It's like, wow, what happened? Because we are not by default inheriting anything. So let's go copy source attributes. So every particle that gets copied from our original particle will inherit the attributes. Let's add a bit of a noise. So what can we do with the noise? We can say, I think the originals for now is fine. And then the shape, this part is going to give us better distribution. Velocity stretch, you can change it to scaled. And now we're getting straight, the gaps getting filled up really well, but don't make it too much, because these are going both ways, so it's going to go ahead of your debris. So let's go 0.2 maybe. Uniform scale 0.89. okay, and so this is no, so let's compare this before, after. Okay, so where are my, I'm gonna change the point visibility to a point so you can see easier. Okay, so let's maybe let's make them a little bit bigger. So before, after. So it's gonna give, it's gonna fill up, it's gonna fill in the gaps. Okay, let's plug this guy in here, because this guy was killing anything that has a 0 less than 0.25 color, so we didn't want to emit. We're gonna bring down the point size to 3. And okay, so then the other thing we want is that I noticed that so this is the dust that is lifting off these rocks, right? Debris. So as soon as they're off the surface, they have to slow down super quick, because it's just dust, and there's a lot of air resistance, because this thing is going really fast. And so what I did is, instead of relying on the original vectors, I'm going to put a point warp. Where are you? Okay, here. And I'm going to use turbulent noise, hooked up to position, and I'm going to plug this guy in CD, and this is gonna give me some random colors. And this is not what I want. I'm gonna change that to a 3D noise, and then it's gonna give me a lot of random colors like rainbow. But now the frequency is too high. I don't want that. I want a low frequency, and why I'm going to do that now I'm going to explain. So now each of these grouped colors are representing a vector, right? Like one is looking up, one is looking down, one is looking left. So now this way I'm going to be able to get a bit more shape volume, because if I mean, maybe some of you now say, if you want to create random vectors, why not use attribute randomize? It does everything out of the box, and you're right. It does create random attributes very fast. And if there is a feature that what I'm after, please let me know. But because what I'm trying to achieve is a bit different, I would say. So if I put these vectors to 100, and if I go show me the vectors, so it's gonna give me all these vectors drawn, but they are looking all over the place. And this is not what I'm after. Let me hook this guy up here so it's a bit easier to see. But this is not what I'm after. Because what's going to happen is that this guy is going to give me a complete noisy simulation. And then I'm going to waste so much of those voxels with just noise. Instead, what I'm after is some kind of proper distribution. So we get some areas bigger mushrooms, some areas smaller mushrooms, but because we have disturbance, etc., that's going to be taking care of the mushrooms. That will take care of the mushrooms as well. So now if I plug this guy to velocity, now the values are way too small, but if I increase the amplitude maybe to something like, I don't know, let me do a little guess, 100. And now I have some distribution happening, and that's gonna, I think, create a lot more interesting vectors than just randomizing them. Let's increase the maybe roughness to 0.8. Okay, so that's gonna give now much more interesting detail for sure. That's why I prefer to do it this way. Okay, so that's good for now. I think that will do the trick. And if you wanted to increase, if you want to make it a bit more interesting, you can always take this guy, duplicate it, maybe make higher frequency with less amplitude and add it on top. So all these chunks of, I need to put that back to 1. All these groups of vectors then will get tiny additional randomized colors, but it's going to sit on top, so it's going to maybe push it back, push it down. You can maybe even multiply, so maybe we can just do that, right? Let's do that. So what if I copy pasted this guy and said 1, 1, 1, and but this time, well, the other one was we were going to make it 100, so let's make this one 0.2. And let's multiply. Then let's maybe change just give it a bit more different value or so. And let's multiply this guy with this guy. Okay, that should give me. Where did they go? Oh yeah, because we are deleting down the line here. That really got rid of a lot of them. So maybe let's go 0.9. Okay, so. Maybe let's add it, because we have to rebalance it if you multiply, because you're dropping the values down. Maybe if you add it, and it's kind of working. It's now maybe too much. So this should now give even more interesting results. Okay, maybe we can go a bit more. 4. So this is before. This is after. Okay, so that's more. No, it's gonna give you more detail. But I'm gonna stick to my original values because I don't want to get surprises. And so this is what I did, and that's the value you want to go, at least for this test. And plug the output of noise to V as in velocity, and make sure that this is set to 3D noise. Okay, and what we're gonna do is that we are going to now cache this out, which I have in advance. So that kind of gives a better solution to our standard problem. We used to have super tiny dots. We still have some, but don't forget that this is we can always push this. It's a bit of a low res sim, and also we can, I think I cached this out with a bit less points, and also we are looking at the viewport without motion blur, so I guess there's still a lot of room to cache this out in a better way. So, and now the other thing that I wanted to mention before we move on to shading and rendering is for you guys to go back and think how you can utilize this whole setup we've been preparing together for 10 plus hours, I believe, and how to make a better use of this. And it goes like this. So let's put this on. Let's go to mountain tip. Let's put the geometry on. I think it's this guy, mountain sim, yeah. And let's bring in our ship for our discussion. Okay, this is our ship. So because we have a few shots where we can make this very interesting. So this is not this camera, that's shot 3. So in shot 3 we have a moment where I believe we can take good advantage of, which is this breakup, right? Which means that, remember that ship smoke we made, this guy, and we made it to be used in a few shots, right? It was 2A, which starts from 960. So if you got 960, because this sim looks okay at this range, right? It has a lot of detail, and which I will probably do this again to have a bit less emission at the beginning, so it doesn't cover our object so much. And but what happens when this guy comes really close? It's not the shot, sorry. This guy. We're losing detail. Still not the right camera. We're losing detail here. So we need to take care of this, right? And we're going to lose more detail. I think we cached this out for a long time. Yeah, so obviously this quality will not hold. But then we cannot also always simulate stuff that is gonna look so good in such big containers. So we need to optimize our scene, we need to optimize our workflow. And this is some of the problems that we always face in the industry. Like, we are limited with a container size and RAM and all that jazz. So what I would do is that go to a good frame. This is my frame, right? So it's 1072. I'll go, let's say 50 frames. Go into ship smoke cache. Duplicate this guy. Now put on the side, say ship smoke column shot 3. And change the start frame to maybe 1050 and emit for, like, key the emission to start from very low values to the moment it hits the actual value when our ship hits these rocks, right? So you do like 100 frame or 50 frame pre-roll, and around this time you reach the full quality. And for this other ship smoke sim, you can now in this next one, you can now maybe have a very high, not very high, but maybe higher dissipation, because the camera, wait, we are caching up, because the camera is turning left here. So we don't care about here, like literally if you have dissipation happening around these frames, you don't care, because in VFX If you don't see it, you don't care. It's because if you don't see it, they don't pay. It's not important because we work for what's in the frame. Okay, no director is going to ask you, but this simulation is low res there and this, unless the camera is not locked. Maybe it's gonna be a problem or whatsoever, but ideally this is not a problem. If it's not in the frame, you don't care. Okay, so then you have your high-res sim, this time using the same settings. You don't have to recreate anything, and then hey, you can use that in the next shot even better, because this one is just going into your frame from off frame, so you can have so much more detail using the same rig. Most likely you'll have to play with the settings, you know. I don't think there's one good setup that works under all circumstances. So I'm gonna save this now as PyroSim 2. Yes, I already saved it. And in the next lesson we're going to start shading and rendering and lighting.